Chapter 6 Deployment Scenarios. In this chapter we provide some examples along with their corresponding requirements and briefly introduce how to use the functions shown in the previous chapters to fulfill those requirements. Example 1. Isolate the machines with / without internet access. In this example, we would like to place the machines with / without internet access into different zones. For security reasons, the machines for internal business operations are not allowed to have internet connections. The machines with internet access cannot initiate network connections to those machines for business operations. Let's recall the section for Zone DMZ in the chapter of border control. T is forbidden for those hosts in Zone DMZ to initiate network connections to those machines in Zone LOC by default. Illustration 160, Zone DMZ rules. Thus, we can place those machines with internet access into the Zone DMZ, and the machines for internal business operations into Zone LOC. But Zone LOC are allowed to access Zone Net by default. Therefore, we need to add extra rule to block access from Zone LOC to Net. This can be done via border rule. Add rule as follows. Illustration 161, block the access to internet from Zone LOC. A lot of office environments are based on this configuration by placing internet servers into Zone DMZ by proper port forwarding setup and place the other hosts into Zone LOC by restricting the internet access. But this configuration is with more applications. Assume there is a requirement to ask that each person in the office is with 2 desktop machines, one is for internal business use, the other is for internet access. The machine for internal business use is forbidden to access internet directly. To fulfill the requirement, those machines for the use of accessing internet can exist in the form of virtual machines in Zone DMZ. The person can browse the internet by using VNC client, SPICE client, or Microsoft Remote Terminal. If the OS in virtual machine is Microsoft Windows, from his/her machine for internal business use to those virtual machines in Zone DMZ and use the browser from the virtual machines to access internet. Therefore, it reduces the chances that the machines for internal business uses are compromised. Illustration 162, use virtual machines for internet access. Please note that you are connecting to base platform's IP address, for example, the IP address of BR0, and TCP port from VNC client. In the diagram above, the machine TA is with VMAS console displayed on its screen via VNC. From that VMAS console, he/she can access the internet from the programs installed on VMA. Example 2. Use VPN to access virtual desktop while using VNC client, or SPICE client, to access virtual machines within base platform. Please note that the VNC client should connect to the IP address, ES, of the base platform, not the IP address of the virtual host. Therefore, while using VNC over VPN, you should use the IP address of the base platform in VPN, the first IP address of the address pool for VPN use, 172.16.38.1 by default. Once you have the console of virtual machine passed back from VNC, you can use that virtual machine to access the other machines in the office governed by the network policies. Illustration 163, access virtual machine via VPN. In the diagram above, the console of VMC can be accessed via VNC over VPN from the place outside the office. With the console of VMC at hand, it is easier to access the other machines in office. In this way, it is not necessary to grant the other subnets access to VPN client directly, and some other authentication scheme can be enforced in the virtual host VMC. Example 3, SBC or firewall virtualization. SBC and firewall are known with at least 2 network interfaces, one is connecting to the internet, and the other is connecting to the private network. Thus, to create a virtual for the use of SBC or firewall, just provide the network interfaces for this virtual machine into BR0, for WAN connection, and BR1, for LAN connection. To use the SBC or firewall, just use the LAN IP address of this virtual host as the gateway to redirect the traffic. Illustration 164, SBC or firewall virtualization. Example 4, place storage system in another subnet. Illustration 165, use dedicated subnet as storage area network. The base system might not be able to provide sufficient storage space for the virtual machines. The diagram above can be used as reference for this type of applications. Server A and Server B are used as the servers for the subnet connecting to BR1, but they are with extra network interfaces in BR3 to connect to an external storage system by using ISCSI. In other words, the subnet where BR3 resides is used as storage area network. Example 5, multicast router with multicast sender. The following diagram is an example to use the base system as a multicast router and the multicast sender resides in the virtual machine. The border control, firewall functions, has been turned off so that we do not have the labels for net, DMZ, and LOC on the diagram. Each subnet is of the same role. If border control is turned on, please note net and DMZ are governed by the rules we mentioned earlier so that multicast routing does not work for these 2 zones. To make multicast routing function on the base platform, just turn on PIM. Illustration 166, Multicast router with multicast sender. In the diagram above, a multicast sender is installed in a virtual machine attached to BR0. As far as the base platform is concerned, it only needs to turn on PIM. The rest of the work will be dependent on the multicast sender and receivers. The TTL, time to live, setting in the multicast packets at least should be larger than 1 to go across the router to reach the other subnet. Each time when a multicast packet go across the router, the value of TTL will be decreased by 1. Once the value of TTL is less or equal to 0, the router will stop forwarding the packet. Some of the people might use the open source package VLC to test multicast sending and receiving. At the moment of writing this document, the default setting of TTL in VLC is -1 so that its multicast packets cannot go across its own subnet by default. You need to change that setting while using VLC as multicast sender. Otherwise, the multicast sender and receivers can only reside on the same subnet. We do not want this document as VLC tutorial, we just provide some hints for VLC to function as we expect. The following screen snapshot is about where to modify the TTL value in VLC. Illustration 167, example of TTL setting in VLC as multicast sender.